Now, data integrity is achieved through hashing. Now, hashing is simple, it's like some kind of CRC, some kind of checksum, some kind of CRC. Now, there are two kinds of hashing algorithm that we can use to create a unique fingerprint, a unique checksum for every data packet. This is MD5 hashing algorithm or the SHA hashing algorithm. The algorithm will create a unique checksum or hashing number unique to this string of ones and zeros in the data packet. And lastly, VPN, IPsec VPN has to make sure that we are communicating with the correct end device, and this is through the use of authentication. Now, how do you know that this is the right person? Well, you have to make sure that you are talking to the right person through authentication. Now, authentication can be achieved using PSK, or what we call pre-shared key, or RSA signatures. Now, for the book, you just know you use PSK or RSA signature. So these are additional information. Now, authentication is to make sure that you're communicating with the right person. So we can use hashing solution to make sure that you are talking to the right person. So using pre-shared key, the idea is I don't care how we send a key to each other, but a key has been sent to each other. So maybe I make a phone call to the other side and tell them what is the hashing key to use, and they configure onto the remote device. So that's why it's called pre-shared. We don't care how you share the key, but it's pre-arranged. Okay, so once this pre-shared key has been set up, to make sure that you are the right user, we will use things like MD5. So if you tell me that you're the remote office router, how do I know you're the remote office router? I will send you a message, a test message, and you're supposed to use hashing to come up with some kind of hash result to the test message. So, and I also do the same hashing using this pre-shared key. So if the hash result is the same, then you must be the right person, because only you and I have been given the same hashing key, so as to produce the same hashing results. So in this first example of using PSK, we're using hashing to support our authentication requirement. Now, the other way is what we call the RSA signature. Now, remember the idea of public key and private key? Remember the idea of public key and private key? Well, here, RSA signatures leverages on the idea that I have a private key which nobody knows, and I have a public key which I freely gives to people. Okay. Now, RSA uses what we call a asymmetric encryption. What it means is you use one key to do encryption, and you can use another key, another related key, to do decryption. So if you can decrypt my message using the public key, because I'm using the private key to do encryption, and remember, the private key is never being sent out to other people, right? So if you can decrypt the message using my public key, if you can decrypt the message using my public key, then what happens is, then it must be from me, because only I have the private key to do the encryption, to be unlocked by the corresponding private key. So in a sense, we're using encryption, asymmetric encryption, to facilitate authentication. So remember, because in the bottom, at the back of our mind, we are so used to the idea of Windows authentication, whereby you simply support some kind of username password concept. You just supply username password. Here we do not use username password. Here we use hashing to support our authentication, or we use encryption decryption to make sure that you're talking to the right person. So IPsec, when it was created many years ago, comes in two flavors, AH or ESP. Now ESP basically means IPsec with encryption. Okay, here means IPsec with no authentication, with no encryption, only hashing and authentication. Only hashing and authentication, because in the old days encryption is very CPU intensive, and in the old days we may not have enough processor power to facilitate the encryption decryption fast enough. So we can opt to have no encryption in this IPsec connection. But of course these days, when we talk about IPsec, automatically we are assuming ESP, because encryption is what we want. So AH, even though there is such an option, authentication header, means IPsec without the encryption option. So this AH method these days is no longer used, because encryption is becomes part of the IPsec default requirement these days. Now one thing I want to highlight is IPsec is a framework. So what does it mean? Well, it doesn't tell, it spells out what objective it wants to achieve. We need to do authentication, we need to do encryption, and we need to do some kind of hashing, for example. Okay, but specifically we don't tell you how to do it. So you can incorporate, so we can easily incorporate whatever that is currently available in the industry, okay, into our, we can use whatever, this is hashing, okay, so we can use whatever current encryption standards available in the industry to keep our IPsec solution up to date. Okay, now just to give you an example, okay, SNMP, which is a management protocol version 3, they talk about supporting encryption. They talk about supporting encryption, but in their solution they already hard-coded what encryption solution they want to use. So imagine this, so as time goes by and as more and more powerful encryption services comes online, your solution becomes outdated, becomes less secure, right? Well, not with IPsec framework idea. Like I said, we don't tell you what specific encryption to use, so you can grow with the industry. So as the industry invents more and more sophisticated encryption protocols, you can easily incorporate them into this framework. So this framework doesn't specify exactly what to do. It tells you what you must do, but it doesn't tell you how to do it. So it leave it loose so that we can incorporate the latest upgrades into from the industry. Likewise for the hashing standard. Okay?